Hello, this will be a demonstration of proposition 4 from book 7 of Euclid's Elements, which says that the lesser of two numbers is always either a part or parts of the greater number. What we're given then is two numbers, BC and A, such that the number BC is less than the number A, and it is either going to be the case that the number BC is a part of the number A or it is parts of the number A. Now first, either the numbers A, B, and B, C are prime to each other, or they're not prime to each other. If they are in fact prime to each other, then the number BC is going to be parts of the number A, because what we can do, we can divide the number BC into its units. We know that we can do that because a number is a multitude of units, and each unit of the number BC is obviously just a part of BC. But the number A is also composed of units, right? Being a number, just by definition, 7, 2. So the units in BC are going to be parts of the number A, which means that the number BC is going to be parts of the number A. Now, if the number A is not co-prime to the number BC, then either the number BC measures the number A or it does not. If the number BC does measure the number A, then it's obvious that the number BC is a part of the number A, just by definition 7, 3. But if the numbers BC and A are neither co-prime, nor does the number BC measure the number A, we're going to take the number D as the greatest common measure of the numbers AB and the number BC. And then we're going to divide the number BC into parts which are equal to the number D. So we're going to have the parts BE, EF, and FC, for example, all being equal to D. Now, because the number D measures the number A, we know that because we made the number D as the greatest common measure of the numbers A and the number B, BC. So the number D measures the number A, which obviously means that the number D is a part of the number A, just by definition 7, 3. But the number D is also equal to the numbers BE, EF, and FC, so that each of these three numbers, by a property of numbers, also is a part of A. So the numbers BE, EF, and FC are also parts of A, which then means that their sum, the sum of these three numbers, is going to be parts of the number A. But their sum is just the number BC, so the number BC is parts of the number A. And this is all that we set out to prove. Given any two numbers, the less is either a part or parts of the number of the greater number, and we've thus proven that. These are all the possible cases. So we're done with the proposition, therefore, etc. Q, E, D. Now, this language of part and parts is a little obscure, just using the terms themselves. How we would understand them now, we would understand part to be a factor of a number, and we would understand parts to be a proper fraction of that number. So let's go through some examples. I'm going to set the number BC to be 6. So the number BC is equal to 6, and it's just going to be 6 in all three cases. Now, a case where the number BC is prime to the number A would be if number A equals 13, right? So this is going to be our first case where the numbers BC and the number A are co-prime to each other. And if this is the case, then the number, BC, or not BE, BC, is parts of A. And what this is going to look like is that, give me one moment. Yeah, there it is. Okay, so the number BC, if it is co-prime to the number A, we prove that the number BC is parts of the number A, and what that's going to look like in this case is that the number BC is going to be 6 1/13 parts of A, right? Because we have the number A equal to 13 in this case, it's clear that the number BC, which is equal to 6, is going to be 6/13 of A. Now, each 13th of A is just the unit, because the number A is equal to 13. So again, this is just going to mean that the number BC equals 6/13 of the number A. And this again gets us back to the language of parts as proper fractions, because 6/13 is a proper fraction as opposed to something like 13/6, which is improper. Proper being where the numerator is less than the denominator, improper being where the numerator is greater than the denominator. But here we have a proper fraction, 6 is less than 13, so the number BC is parts of the number A. Now our second case is where we're going to have a BC equal to 6 again, and BC is going to measure A. So an obvious case of this is going to be where A is 12, right? 6 obviously does measure 12, which means that 6 is a part of 12. Specifically, it is 1/2 part of 12. Now, our third case, where the two numbers are not co-prime to each other, but the less does not also measure the greater. A case of this would be if BC is equal to 6 and A is equal to 14, let's say. Now, if this is the case, what we do is we take their greatest common measure or their greatest common denominator, and this is going to be 2 here. So D is going to be equal to 2. And then we divide 6 up into 2s. So that's going to give us 3 parts of 6. Or 3 parts of 2 is going to give us 6, because 3 times 2 equals 6. Which means that, So we're going to have 3 2's make 6. But 7 2's make 14, which means that 6 is going to be, give me time to do some math here. Sorry, I should know this. Give me one moment. Sorry, I'm kind of off my game here. If this is the case, then the number BC is going to be, it is going to be, it's going to be 3/7 of 14, right? Yeah, it's going to be 3/7 of A, because 2 is a 7th of 14, and 3 times 2 equals 6. So 6 is going to be 3/7 of 14. Now again, this 3/7 here means that, it's a proper fraction, which means that the number BC is going to be parts of the number A. And these are all 3 possible cases. Either BC is co-prime to the number A, and if it's not co-prime, it either measures it or it doesn't. Those are the only possible cases. So going through all the possible cases and showing that the number BC is either parts or a part of the number A, we complete the proposition. And that's all I've got to say about this proposition, so I'll end the video here and move on to 7.5.